Hello, my dear friends. My name is Jigar Kumar Madhusudan Bhatt. Today I am going to present you a talk on aircraft engines. We travel many times by aeroplane or aircrafts, but we try or we care little to know about it engines and its working techniques. Today I am going to present you a talk on aircraft engines. I'm sure that you would like it very fine. Okay, now let's begin. An aircraft engine, often referred to as an aero engine, is the power component of an aircraft propulsion system. More aircraft engines are either piston engines or gas turbines, although a few have been rocket powered, and in recent years many small unmanned aerial vehicles like drones have used electric motors. Manufacturing industry of these aircraft engines are in commercial aviation. The major Western manufacturers of turbofan engines are Pratt and Whitney, General Electric, Rolls-Royce and CFM International. Russian manufacturers include the United Engine Corporation, Aviadigatel and Klimo. Aero Engine Corporation of China was formed in 2016 with the merger of several smaller companies. The largest manufacturer of turboprop engines for general aviation is Pratt and Whitney. General Electric announced in 2015 entrance into the market. Now there are many types of aircraft engines, but today we are going to discuss only two types of aircraft engines and data, and those are turbojet engines and turbofan engines. They are reaction engines. Reaction engines generate the thrust to propel an aircraft by ejecting the exhaust gases at high velocity from the engine. The resultant reaction of forces driving the aircraft forwards. The most common reaction propulsion engines flown are turbojets, turbofans and rockets. Other types such as pulse jets, ramjets, scramjets and pulse detonation engines have also flown. In jet engines, the oxygen necessary for fuel combustion comes from the air, while rockets carry oxygen in some form as part of the fuel load, permitting their use in space. Now jet engines, turbojet engine. A turbojet engine is a type of gas turbine engine that was originally developed for military fighters during the World War II. A turbojet is the simplest of all aircraft gas turbines. It consists of a compressor to draw air and to compress it, a combustion section where fuel is added and ignited, one or more turbines that extract power from the expanding exhaust gases to drive the compressor, and an exhaust nozzle that accelerates the exhaust gases out the back of the engine to create thrust. When turbojets were introduced, the top speed of fighter aircraft equipped with them was at least 100 miles per hour, faster than competing piston-driven aircraft. In the recent years after the war, the drawbacks of the turbojet gradually became apparent. Below about March 2, turbojets are very fuel inefficient and create tremendous amounts of noise. Early designs also respond very slowly to power changes, a fact that killed many experienced pilots when they attempted the transition to jets. These drawbacks eventually led to the downfall of the pure turbojet, and only a handful of types are still in production. The last airliner that used turbojets was the Concorde, whose March to airspeed permitted the engine to be highly efficient. Now there are another type, turbofan engine. A turbofan engine is much the same as a turbojet with an enlarged fan at the front that provides thrust in much the same way as a ducted propeller, resulting in improved fuel efficiency. Though the fan creates thrust like a propeller, the surrounding duct frees it from many of the restrictions that limit propeller performance. This operation is a more efficient way to provide thrust than simply using the jet nozzle alone, and turbofans are more efficient than propellers in the transonic range of aircraft speeds and can operate in the supersonic realm. A turbofan typically has extra turbine stages to turn the fan. Turbofans were among the first engines to use multiple spools, concentric shafts that are free to rotate in their own speed at their own speed to let the engine react more quickly to changing power requirements. Turbofans are coarsely split into the bypass and high bypass categories. Bypass air flows through the fan but around the jet core, not mixing with the fuel and burning. The ratio of this air to the amount of air flowing through the engine core is the bypass ratio. Low bypass engines are preferred for military applications such as fighters due to high thrust to weight ratio, while high bypass engines are preferred for civil use for good fuel efficiency and low noise. High bypass turbofans are usually most efficient when the aircraft is traveling at 500 to 550 miles per hour or 800 to 885 km per hour, the cruise speed of most large airliners. Low bypass turbofans can reach supersonic speed through, though normally only when fitted with afterburners. Now, this is all for this topic of aircraft engines, my dear friends. I think that you would like it. Please, if you want to know about any other topic, then please write in the comment section. I will make a video on that topic. Please like and share my videos, and also please subscribe my channel. Thank you all. Have a nice time.